So in this lesson, we're going to start talking about exponential functions, and this will be part one of this lesson on exponential functions. Exponential functions are functions whose equations contain variables in the exponent. All right, so to remind you, in the past, here are the kind of functions that you had. So you had something like f of x equal x squared. You dealt with f of x equal 2x cubed minus 3x and so on. You dealt with g of x equal 1 over x plus 1, things like this. All right, so in previous courses and previous lessons, these are the type of functions you dealt with. Now, these are not exponential functions, so these are not exponential functions. Remember, an exponential function is a function whose equation contains a variable in the exponent. So these are examples of exponential functions, and you're going to graph things like this in this lesson, and the previous lesson, and the next lesson. Sorry, exponential functions. So, for example, f of x equal 2 to the x. So notice that the variable is in the exponent. Now, these are not exponential functions because the variable is not in the exponent. The variable is the base here. So you see your exponent is a real number. Your exponent's a real number. Your exponent's a real number. This is understood to be 1. Okay, here your exponent is a real number. It's understood to be 1 here. All right, so an exponential function, you have the base being a real number, and we have to talk a little bit more about what the base should be, but the exponent has to contain the variable. So here's another example that you're going to deal with. So for example, suppose we had 1/3 to the x power. All right, so notice sometimes your base are improper fractions, like 2 over 1. Sometimes your base are proper fractions, like 1/3. Okay, so these are all examples of exponential functions that you're going to have to deal with in the next lesson. So, for example, 2 to the x minus 3, that's also an exponential function because the exponent contains a variable. So these are examples of exponential functions. Now let's talk more about what these bases should be. See, this base is a 2, this base is a 1/3, and this base is 2 as well. So in terms of what the base should be, let's discuss what an exponential function is. So here's the definition. So the definition of exponential function is this. Is defined as f of x is equal to b to the x. So some b raised to the x power. Now remember, f of x means the same thing as y, so just keep that in mind. Now it's also defined as since f of x is the same thing as y, we can say y equals b to the x. Okay, so just remember that it can be written in function notation, or it could just be written with the variable y. But b must be positive. Must be a positive real number. So b must be positive, and b cannot equal 1. So b must be positive, but it can be any positive number but 1. That's what that's saying. Now there's a reason why b cannot equal 1, and we'll discuss that in a little while. But remember, b must be bigger than 0. Okay, cannot equal 0. It must be bigger than 0. It must be a positive number, and it can be any positive number but 1. So notice that these are all positive numbers. Your bases here are all positive numbers. Okay. All right. Now, let's talk about why your base cannot equal 1 for the moment. All right. So if the base were 1, so if b was 1, we would have f of x equal 1 to the x power. Okay. Now remember, 1 raised to any power. 1 raised to the second power is 1 times 1. That's 1. 1 raised to the third power is 1 times 1 times 1. That's 1. So 1 raised to any power, whether it's positive or negative, that's 1. But y equal 1 is a linear function. Okay, that's a linear function. All right, it's not an exponential function. Okay, so it's a linear function. It's not an exponential function. So that's why the base cannot equal 1. Now, in terms of x, remember I was saying if x is 2, we get 1 times 1 is 1. If x is 3, we get 1 times 1 is 1. But x could really be any real number. So x could be any real number. So x is any real number. So I could have said if x is negative 2, 1 raised to the negative second power is still 1. If x is 0, remember x can be 0, x can be any real number, but b must be positive. Your base must be positive and it cannot equal 1. So if x is negative 2, so if I take a calculator and raise 2 to the negative 2 power, I'll get a real number. Okay, so let's talk about that. Let's go to using a calculator right now. So make sure you can use your calculator with these, because when you graph these exponential functions, a calculator does become helpful. All right, so let's evaluate each of the following functions. Let's see. Evaluate each of the following. Okay, number 1, let's start easy. Let's just say we had 2 to the negative second power. Okay, 2 to the negative second power. All right, now you had something like a negative exponents in the previous course. You may have forgotten about what to do with negative exponents, but in the previous course, remember you want to rewrite the negative exponents with positive exponents. So you and remember if you don't remember this, use your calculator. But it turns out that 2 to the negative second power can be written as 1 over 2 to the positive second power, which is 1 over 4, which is, as a decimal, 0.25. But you didn't have to remember any of this from a previous course, although it would have been helpful. You really need to remember as much as possible from your previous courses. But remember, any base raised to negative power, you always wanted to rewrite it with a positive exponent. So there's some rules with this that you used in previous courses. But if you forgot this, all you have to do is just say, on your calculator, you would say 2 raised to the, so use this right here, 2 raised to the, and then negative second, make sure you say negative second, then press equal, and you get 0.25. Okay? All right, what about number 2? Suppose you had 3 raised to the 1.6 power. Now that you cannot do in your head, because that's a decimal. So you have to use your calculator. So 3 raised to the 1.6, so say 1.6, just like this, equal, and you get, let's do the nearest 10. So you get about 5.8. 5.8. So that's about 5.8. 3, suppose you had 1/2 raised to the negative 1. Let's say 0.2. So 1/2 raised to the negative 0.2. So you'd say, now in here you got to use parentheses. You can't just say 1 divided by 2. You got to say in parentheses 1 divided by 2, close the parentheses, got to look like you see it, close the parentheses, then raise it to the negative 0.2, and you get 1. Let's do the nearest hundredth this time, 1.15. So about 1.15. All right. Now number 4, suppose you had 3 to the square root of 3. Let's say 5. 3 to the square root of 5. All right, so on your calculator, you're going to say 3. The base is 3. So you say 3 raised to the, now you press the square root button. So that's going to be, you have to use your second function to get to it. All right, so it looks like this. And then you're going to type in 5, close the parentheses, and then press equal. And you get, let's say 11.66. 11.66. Okay? And then 5, suppose we had 2/3. raised to the negative square root of 7. So 2/3 raised to the negative square root of 7. So again, use parentheses. So you're going to say parentheses 2 divided by 3, close the parentheses, raised to the, and then you're going to say negative square root, and then you're going to type in 7, close the parentheses, and then press equal, and you get 2.92 to the nearest hundredth, 2.92. Okay? All right, now, in a little while, we're going to talk about another base that's called the natural base. It's called the natural base. And so we're going to look at another irrational number. So we're going to come back to evaluating each of the following in a little while. Okay, and what we'll do next is this. Let's start looking at graphing an exponential function, see what it looks like. All right, so let's graph each of the following. All right, graph each of the following. Okay, number 1. Suppose we had y equals 2 to the x power. Okay, y equals 2 to the x power. All right, I'm just going to use a t-table. Now remember, I can use any number for x. So we're going to use positive numbers, we're going to use 0, and we're going to use a couple of negative numbers. Okay, so that's the way we're going to do this. So we're going to use a t-table. Use a t-table. Yeah. So we get, if x is, let's say, 0, I get y equals 2 to the 0 power. Now, if you don't remember what 2 to the 0 power is, use your calculator. But remember, 2 to the 0, any non-zero number raised to 0 power is 1. But again, if you didn't remember that, use your calculator. So if you type in 2 to the 0, 2 raised to the 0, oops, you're going to get 1. So you just get a 1. So I get the 0.01. If x is, let's say, 1, I get y equals 2 to the 1, which is 2. If x is, let's say, 2, I get y equals 2 squared, which is 4. Let's do a negative 1. If x is negative 1, I get y equals 2 to negative 1. Now use your calculator on this. If you don't remember how to deal with negative exponents, use your calculator. So you can say 2 raised to the negative 1, press equal, and you get 0.5. And it kind of makes sense because if you did remember the rule, so the rule would be to rewrite this as 1 over 2 to the positive. Remember when you rewrite, see how this is in numerator, you bring this to the denominator and you make the exponent, you change the sign of the exponent, so negative 1 becomes positive 1. That was one of the rules you discussed in the previous course. So that's just 1/2, which is 0.5. But again, if you didn't remember the rules, there's no big deal for this. Just use your calculator. You have access to a calculator. So I get 0.5. If x is, let's say, negative 2, let's see what we get. I get y equals 2 to negative second power. Again, if you know your rules, so use your calculator just in case you mess up, but really this is going to be 1 over 2 to the negative second power equals 0.25. Oops, sorry. 0.25. Now your rule would say 1 over 2 squared, which is 1/4, which is this. All right, now, so let's just see what it looks like in terms of a graph, and let's see what we can do with it. Now we may need to plot a couple more points just to emphasize a couple of things. So in your calculator, I'm sorry, in your graph paper, you're gonna plot 0, 1, which is here, 1, 2, which is here, 2, 4, which is here, negative 1. Okay, so now negative 1, 0.5, so it's about here, and then negative 2, 2.5, so that's about here. And so I want you to notice something. As I draw the graph going to the right, so let's look at this in terms of the right, starting here though. As I draw the graph going to the right, and let's go ahead and pick another number for x. Let's say x is 3, just to kind of see what's happening. If x is 3, I get y equals 2 to the third power, which is 8. All right, so I get 3/8, which is way up here. So as I do this, notice that my y value, see how my y value here, when I go each unit for x, my y value is 2, then it increases to 4, then it increases to 8. So it's rising very rapidly. So I just want you to remember those words. As I go to the right, my y values are going to be rising very rapidly. So hence the word exponentially. So it's rising rapidly. But I want you to think about this as I go to the left. As I go to the left. So as I go to the left, my y values are getting smaller and smaller. See how my y value is 0.5, then 0.25. And if I went a little bit further, let's say -3, I get y equals 2 to the negative third power, which is about, on your calculator, approximate this. So 2 to the negative third, so 2 raised to the negative third, you get about 0.13. So it's exactly 0.125. But when we graph it, let's see how this is. This y value is 0.25, so this is going to be a little closer to the x-axis. So let's say it's about here. I'm doing the best I can with this. But I want you to notice something. Alright, so you just draw it like this with an arrow. Now I want you to notice something. And listen carefully to this. So this is what the graph looks like. So that's the graph of an exponential. So on one end, when you go to the left, your y values are getting smaller and smaller and smaller. Okay, they're not. When you go to the left, they're not falling rapidly. They're falling slowly. Whereas over here, when you go to the right, your y values are increasing rapidly. They're rising rapidly. Okay, now I want you to notice something. See these y values? As I keep going, those y values are never going to be negative, which means I'm never going to get, in this case, in this function, I'm not going to get any y values that are below the x-axis. Think about this. The base is positive. A positive number raised to any power. Look, a positive number raised to any power, positive, 0, negative. Look at all these y values. These y values are all what kind of numbers? They're all positive numbers. So they're all going to lie above the x-axis. This is never 0. 2 to no power is ever going to be 0. So it's never going to cross the x-axis. Now, as I go to the left, I want you to notice something. As I go to the left, keep on going to the left. Your y values keep getting smaller. I want you to notice it's the graph, when you go to the left, is going towards the x-axis. See this right here? So your y values are getting smaller and smaller and smaller towards the x-axis. So that x-axis right here, this right here, I'm going to use a dotted line to indicate it. This x-axis right here is called the horizontal asymptote. Horizontal asymptote. So all exponential functions are going to have a horizontal asymptote. So the horizontal asymptote here happens to be the x-axis. Okay, so that's the x-axis. Another way, remember, this is a horizontal line, so another way of naming the x-axis, remember, is y equals 0. So your horizontal asymptote is the x-axis, or you can say y equals 0. So all exponential functions, have a horizontal asymptote. Okay, so all exponential functions have a horizontal asymptote. All right, so what we did here was we graphed 2 to the x, use the t-table, plot your points. The function here is rising rapidly. Over here, it's decreasing very slowly, but it's going towards the x-axis. So your x-axis is called the horizontal asymptote. It's wherever this part that's falling slowly, whatever horizontal line it's going to. So it's going towards the x-axis. All right, now let's talk about this in relation to the next one. Suppose I wanted to graph this now. Number 2, y equals 2 to the x minus 3. Okay, y equals 2 to the x minus 3. I'm going to go back and I'm going to put this on a transparency. And then we're going to talk about transformations in terms of this. So when I graph this, remember I got this point. Let me do this. So I got this point, this point, this point, this point, this, and then this, and so on. So here it rose rapidly. It rose rapidly. And then here it fell slowly, meaning that the y-axis is the y values rather are getting smaller and smaller and smaller. Now, keep in mind though, be careful. This is not really. This doesn't become a horizontal line. Remember, your y values keep getting smaller, but at a slower rate. They don't fall as rapidly as this rose rapidly. So I'm trying to get rid of that light. So it's just getting closer and closer. It is still falling. I can't align this anymore. Okay, so it is still falling, but it's not. Remember, when you do a horizontal line, it means that y values are the same. These y values are never going to be the same. They keep getting smaller and smaller and smaller. Okay, so all right, so that's what the graph's going to look like. Now, what I want to let me go ahead and draw the horizontal asymptote. So the horizontal asymptote, just like the x-symmetry. Remember the x-symmetry for quadratic, we use a dotted line. Use a dotted line for the horizontal asymptote. Use a dotted line for the horizontal asymptote. So it kind of looks like this. Okay. Now, let's go ahead and graph this one. Now, I want you to notice. Now we're going to do a t-table, but I want you to notice in terms of transformations is this. Okay. So when I remember, just like with transformations in a previous lesson, see that number's on the outside, -3. That's a vertical translation. So that means you're gonna take the this function to the x, and you're gonna shift it down 3 units. That's what that means. You're gonna shift it vertically down 3 units. In other words, you can end up with something that looks like this. Just like this. All right. So you're gonna go down 3 units. So 1, 2, 3. Now I want you to notice a couple of things, and that's going to help us with what we're about to do. What is your horizontal asymptote now? So your horizontal asymptote is no longer the x-axis. Your horizontal asymptote is what line? What's y equals, and what is this x in this y coordinate? It's -3. So your horizontal asymptote is y equals -3. Okay. Now, in terms of your function, here's how you can determine your horizontal asymptote. Remember, we said that all exponential functions have a horizontal asymptote. So here's how you determine your horizontal asymptote. You can determine it right away. Okay, so remember your horizontal asymptote here. I'm going to go ahead and rewrite it again. The horizontal asymptote here is y equal 0. Remember that? All right, so here, what we just saw, your horizontal asymptote is y equals -3. So notice that your constant here, your vertical translation, is going to be your horizontal asymptote. So -3. So you take 2 to the x, remember 2 to the x, the horizontal asymptote was the x-axis, and the reason for that is because 2 to the x I can write as 2 to the x plus 0. So this 0 is your horizontal asymptote, y equals 0, which is the x-axis. Here, your horizontal asymptote is y equals -3. Now remember, just like with the axis symmetry, you got to say x equal y equals. In this case, since it's horizontal, you're going to say y equals. Okay? All right, so let's go ahead and use a t-table. Use a t-table. And just as before, you're going to use these numbers and you plus some points. Okay? So basically what I would do first, though, is I would go ahead and draw the horizontal asymptote. This is number 2. So y equals 2 to the x minus 3. So draw the horizontal asymptote. So the horizontal asymptote is y equals -3 down here. So you're going to do this. Let me do a thicker color. So you can do this. Okay, so that's your horizontal asymptote. And then we're going to draw the graph. All right, now, if x is 0, I get y equals 2 to the 0 minus 3. 2 to the 0, remember, if you don't remember it, but use your calculator, but 2 to the 0 is 1. 1 minus 3 is a -2. Use your calculator if you're having issues with sign numbers as well. So I'm going to plot the point 0 and -2, and so this is what I get. Very simple. I get this. Plot the point. But again, you got to plot at least 5 points. Use some positive numbers, use some negative numbers. Because remember, part of your graph is going to rise. Now, we're going to talk about rising here. Part of your graph is going to rise quickly, and then as I go to the left, is going to fall not as quickly. The y values don't get the 5 values are getting smaller and smaller, but not rapidly. All right, so if x is, let's say, 1, I get y equals 2 to the 1 minus 3. So that's 2 minus 3, which is a -1. So I plot the point 1, -1. So 1, -1 is here. If x is 2, I get y equals 2 to the second power minus 3. So that's 4 minus 3, which is 1. So I plot the point 2, 1, which is here. If x is 3, let's see if we can put in a 3. If x is 3, I get y equals 2 to the third minus 3. So that's 8 minus 3, which is 5. So 3, 5. So on this side, I want you to notice what's happening. So remember what an exponential function looks like. What part of it looks like this. So it's going to, in this case, it's rising rapidly. Okay. And on this side, remember, on this side, your graph's going towards the x-axis. I'm sorry, towards the horizontal asymptote, which is y equals -3. So it's going to do this. All right, but something like this. But let's just use a negative number and see. So this was 5. So if x is, let's say, -1, let's see what happens. I get y equals 2 to the -1 minus 3. Now use your calculator on this. So 2 to the -1 minus 3. So 2 raised to the -1 power, then subtract 3 equals, you get 2.75, -2.75. And so that's about, let's see, we said -1, -2.75. So that's about here. Okay? And so basically, you're just going to draw something like this. Just draw something like this. And you're done. There's your graph. You're making it look like it's going towards the horizontal asymptote. Okay, so that's what this graph is. All right. Now I want you to notice something, and that's going to be important. If I go back to the first 2 that we did, and I want you to notice the graphs. Remember increasing, decreasing functions? As I go from left to right, what do you notice about my y values? Well, the y values here are increasing. Okay, so remember that was number 1. That was y equals 2 to the x. So they're increasing. Here, when I did this one, y values are increasing as well. Okay, let's look at this one and see, well, when would it be decreasing? So let's look at this for a moment. Let's look at this one. So let's suppose you want to graph number 3. Let's suppose you want to graph y equals 1/2 to the x. Y equals 1/2 to the x. All right, now remember, this is an exponential function. Right away, you can tell me what the horizontal asymptote is. What the horizontal asymptote is. So remember, there's no number out here, so you can write this as +0. So you can write this as y equals 1/2 x to the x power plus 0. So your horizontal asymptote is this number right here. So you can say y equals 0 or the x-axis in this case. Okay? All right, now let's use the t-table. Let's see what happens. If x is 0, I get y equals 1/2 to the 0 power. And 1/2 to the 0 power, remember, is 1. Now, if you didn't know that, if you don't remember that a non-zero number raised to 0 power is 1, then use your calculator. In parentheses, you're going to say 1 divided by 2, close the parentheses, raised to the 0 power, and you get 1. If x is, let's say, 1, I get y equals 1/2 to the first power, which is 1/2. If x is 2, I get y equals 1/2 to the second power. Now use your calculator if you need to. So you're going to say 1/2 raised to the second power. Press equal, you get 0.25. Right? If x is, now notice what's happening. So before you go any further, just plot these points and see what's happening. So 0, 1 is here. 1, 1/2 is here. 1, 1/2. 2, 2.25 is here. So I want you to notice that when you connect these dots at this point, you're going to get and then we connect all the rest, it will be decreasing. See, you're going to get a decreasing function. And remember in the past, in this one, when you went to the left, this graph was going towards the horizontal asymptote. Here, when you go to the right, your graph is going towards the horizontal asymptote. Remember, the horizontal asymptote is the x-axis. Just make sure you draw an arrow here. All right, now don't make this look like a horizontal line, because it's not. So just make it look like it's decreasing and stop. All right, and then here's your horizontal asymptote is the x-axis. Do the best you can with drawing this dotted line. Something like this. Okay. And now let's see what happens over here. So let's pick some negative numbers. If x is, let's say, -1, I get y equals 1/2 to the -1 power. Use your calculator. 1/2 to the -1 power. So 1 divided by 2 raised to the -1 power equal, you get 2. If x is -2, I get y equals 1/2 to the -2. So when I do 1/2 raised to the -2nd power, I get 4. Now, let's see what that looks like. So -1, 2 is here. -2, 4 is here. And then I just do this. I just connect them and make it look like an exponential function. And that's all you do. So this is number 3. That's a graph of f of x equal 1/2 to the x power. Okay? So notice, I want you to notice this, and this is very important. Notice that this graph was decreasing. Okay? And then notice that this graph is increasing. Look at the bases. This base is 2. This base is 1/2. 2 is an improper fraction. So 2 is an improper fraction. So that's bigger than 1. Remember, an improper fraction is a number bigger than 1. 1/2 is a proper fraction. So the numerator is less than the denominator. So it's a proper fraction. All right? So one thing I need to remember is this. And let's go ahead and write it here. So if the base, if b is greater than 1, the graph will increase. Okay? If b, I can't say less than 1. Don't say less than 1. Because remember, if you say less than 1, that includes negative numbers. So you have to be a little bit more restrictive with your base. So you got to say this: if the base is less than 1 and bigger than 0. So if you have any fractions between 0 and 1, then the graph will decrease. The function decreases. Okay? All right, so let's look at this one. Suppose we had number 4. Number 4. So number 4, let's suppose we have f of x equal 1/3 to the x power plus 1. So 1/3 to the x power plus 1. So right away, based on what we talked about, I can say several things. Okay? I can say that the horizontal asymptote is this number here, which don't say 1. You got to name the horizontal asymptote using the equation, so it's y equal 1. I can also say this. Now notice there's no reflection. Remember the negative? There's no reflection. We haven't done anything with reflection yet. But notice that the base is a proper fraction between 0 and 1. So right here, between 0 and 1. So that means that when I graph this, my function is going to be, so f of x is decreasing. All right. So in other words, it'll look something like this. So just make sure your final graph looks like this. Okay. All right. So let's use the t-table. Let's go ahead and first of all draw the horizontal asymptote. So the horizontal asymptote is y equals 1. So here's y equals 1 right here. Okay. That's my horizontal asymptote. And since it's not reflecting, it's going to be above the graph's going to be above the horizontal asymptote. Notice that in all these cases, the graph was above the horizontal asymptote. And the reason for that is because there was no reflection. There was no negative out in front. There's no negative out here. We're going to do 1 in the next lesson, but this number is a positive 1. It's not a negative 1. Okay, so the first thing you do is draw the horizontal asymptote. Now let's plot some numbers. If x is 0, I get y equals 1/3 to the 0 power plus 1. If you can't remember what these are, use your calculator. 1/3 to the 0 is 1. 1 plus 1 is 2. If x is 1, I get y equals 1/3 to the first power plus 1, which is 1 1/3. Okay, so that's equal to 1.33 repeating. Okay. So let's do this. Okay, 1.3 repeating. The 3 is repeating. If x is 2, I get y equals 1/3 to the second power plus 1. Use your calculator with that one. Let's see what we get. So 1/3 parentheses 1 divided by 3. Make sure you put the 1/3 in parentheses. Raised to the second power, and then plus 1. You get something like 1.1. So let's say about 1.1. All right, now here's what's happening in terms of the graph. Okay, so let's plot these three so far. So 0, 2 is here. 1, 1.5 is here. 2, 1.1 is about here. So notice that, remember we said it was decreasing. So that portion of the graph is going towards the horizontal asymptote, which is y equals 1. The other part is going to do this very rapidly. Okay. All right. So as we go to the left, it's going to rapidly increase. Okay. So let's pick a -1. So if y is -1, I get y equals 1/3 to the -1 plus 1. And so let's see what that is. So I get in parentheses 1 divided by 3, close parentheses, 1 divided by 3, close parentheses, raised to the -1 power, and then plus 1, and I get 4. So that's 4. And what's happening is this now. You probably have enough to do this. So -1, 4 is here. And if we want to do one more, let's say -2. I'm not sure if we'll fit on the grid, but let's see. I get y equals 1/3 to the -2nd power plus 1. On your calculator, you have, in parentheses, 1 divided by 3, close the parentheses, raised to the -2nd power plus 1, and you get 10. So this is 10. That was 4. This is 10. All right, and so you get this. So -210 is here. And so notice when I graph this, it rises rapidly, just like this. As I go to the left. As I go to the left, your y values are rising rapidly. So that's how it looks. But it's just, but when you read a graph, you go from left to right. It's decreasing. The graph is decreasing. Okay. All right. So that's number 4, which was f of x equal 1/3 to the x plus 1. All right, let's do one more, and then the next lesson we'll look at some reflections. Let's look at number 5. Okay, number 5, suppose we had f of x equal, let's say 3 to the x minus 5. 3 to the x minus 5. Okay, so right away you can tell me the horizontal asymptote. So the horizontal asymptote is this number here. So it's y equal negative 5. Remember, it's a horizontal line, so you have to use the equation y equal a number. The base is 3. Since the base is 3, which is greater than 1, f of x is increasing. Okay, so in other words, it'll look like this. So that means that this part is going to go towards the horizontal asymptote. Okay, so let's keep that in mind. That part is going to go towards the horizontal asymptote. All right. So first thing I would do is I would graph the horizontal asymptote. So the horizontal asymptote is y equals negative 5. So that's way down here, just like this. And then let's plot some points. Plot enough points to help you draw a graph. So you do have to plot at least 3 points. Okay. So if x is 0, I get y equals 3 to the 0 minus 5. So that's 1 minus 5, which is negative 4. If you didn't remember that 3 to 0 was 1, use a calculator. But you would get negative 4. So I get 0, negative 4, which is here. Okay? And remember, the graph's going to do this. In your mind, that's what it's doing. Okay? If x is, let's say, 1, I get y equals 3 to the first power minus 5. So that's 3 minus 5, which is a negative 2. I get 1, negative 2. So 1, negative 2 is here. If x is, let's say, 2, I get y equals 3 to the second power minus 5. So that's 9 minus 5, which is 4. So I get 2, 4. So I plot the point 2, 4, which is here. So this part looks like this. Do the best you can. Looks like this. Could have drawn a little bit better, but that's okay. Like this. Okay. Now on this side, remember, it's going to go towards this. So this is what it's going to do. It's going to just go this and just do something like that. All right. Just do that, and you're done. All right. So if you want to do a negative number, just to show you, if x is negative 1, I get y equals 3 to negative 1 minus 5. On your calculator, you're going to say 3 to the negative first power minus 5 equal, and it's like what, negative 4.7 about? So that's about negative 4.7. And so when I plot that point, negative 4.7, it's negative 4, so negative 4.7 is about here. So it's, I'm sorry, we said negative 1, so negative 1, negative 4.7, I guess I didn't draw it very well, so it's about here. It should be closer down like this. All right, but that's okay. All right, and then that's it. You're done. So that's number 5, which is f of x equal 3 to the x minus 5. Okay. Notice the horizontal asymptote. We'll always do that first. The horizontal asymptote is always this number on the outside. If there's no number on the outside, then the horizontal asymptote is the x-axis. And then what I would do next is determine whether the graph is increasing or decreasing. Since this number is bigger than 1, it's increasing. If that number were a fraction between 0 and 1, it would be decreasing. Okay? And then you just plot some points, and then you connect them. Just make sure that when you draw, see how it's going towards this, you make it, just make it go down a little, and then draw your arrow. If you extend it and you kind of make it look like it's crossing the x-axis, that's mathematically incorrect. I'm sorry, the x-axis, I mean the horizontal asymptote was mathematically incorrect. So don't ever make it look like it's crossing the horizontal asymptote. Okay, so it's never going to cross, never crosses the graph, so the graph never crosses the horizontal asymptote. Okay? And it's never going to touch it either. So it gets close to it, and that's it. So make it look like that. All right, so that's going to be the end of that one. So that's going to be part one. The part two, we're going to look at some reflections of these.